Welcome to MasterCode. Episode 8, and today we're talking about how to turn your security skills into income legitimately and legally. Bug bounty hunting is the discipline where security researchers test real production applications for real companies and receive payment for verified vulnerabilities. This is not theoretical. Companies pay out billions of dollars per year to researchers through bug bounty programs. Individuals earn six-figure incomes doing this full-time. And the barrier to entry is exactly the knowledge we've been building throughout this series. Everything we've covered from Linux fundamentals through web application security and professional tools directly applies here. Today we're covering the major platforms, how to select the right programs for your current skill level, the Recon methodology that finds targets other researchers miss, the highest value vulnerability types, how to chain low-severity bugs into high-severity findings, professional report writing that gets your submissions accepted and paid, mobile application testing opportunities, subdomain takeover as a scalable finding, automation that scales your coverage, and a realistic picture of the earning potential at different experience levels. By the end of this episode you'll have everything you need to submit your first bug bounty report. Let's get into it. Bug bounty scope is not a suggestion or a guideline. It's the legal contract that determines whether your work is authorized security research or unauthorized computer access. Let me be absolutely precise about this. Every bug bounty program publishes a scope document that defines exactly which assets are in scope for testing and which are explicitly out of scope. In-scope assets are the ones you have permission to test. Out-of-scope assets are explicitly off-limits regardless of what vulnerabilities you find there. Testing out-of-scope assets is unauthorized access. It doesn't matter that you found a real critical vulnerability. The authorization was not granted for that system. Companies have successfully pursued legal action against researchers who violated scope even when those researchers believed they were helping. Read every word of the scope document before you test anything. If you're uncertain whether something is in scope, use the program's communication channel to ask. Do not assume. Do not interpret broadly. Ask. When you find a vulnerability, report it and stop. Documenting that the vulnerability exists and providing clear reproduction steps is your job. After that, everything else is the company's responsibility. Do not attempt to escalate access further to demonstrate impact. Do not access data beyond what's needed to prove the vulnerability. Do not pivot to other systems. The report proves the vulnerability. Data exfiltration proves criminal activity. If you encounter real user data, note in your report that you encountered it, describe what type of data was visible, and stop. Do not download it. Do not save it. Do not reference specific real users. The legal and ethical The bug bounty platform ecosystem has matured significantly, and choosing the right starting platform matters for your early career trajectory. Let me walk through your options honestly. HackerOne is where most serious researchers start and where many stay. The reputation system is public and persistent. Your signal score, which measures the quality of your submissions relative to their triage outcome, is visible to program managers considering you for private invitations. The platform has thousands of programs from tiny startups to the world's largest technology companies. The community forums and Hacktivity feed, which shows publicly disclosed reports, provide a real curriculum for new researchers. HackerOne's disclosure statistics show that total payouts have exceeded $3 billion, which demonstrates the scale of legitimate opportunity. BugCrowd provides strong alternative infrastructure with excellent tooling through their crowd control platform. Their managed programs involve BugCrowd's triage team handling initial validation, which means you get more consistent feedback on your reports. The regular competitive events on BugCrowd are excellent for learning and for placing highly enough to get noticed by program managers. Integrity is the leading European platform with strong GDPR alignment. As European companies increasingly prioritize security compliance, Integrity's programs are growing rapidly. Direct programs from major companies sometimes pay more than platform programs because there are no platform fees. Google's Vulnerability Reward Program, Apple's Security Bounty, and Microsoft's Bug Bounty Program all operate directly with researchers. These are extremely competitive but pay exceptionally well for valid findings. Choosing which programs to hunt on is a strategic decision that significantly affects your early success rate and earnings. The wrong program choice leads to months of work with 0 accepted reports. The right choice leads to your first accepted finding within weeks. Scope width is the most important initial filter. Programs with wildcard scopes like star.company.com give you potentially thousands of subdomains to investigate. Each subdomain is a separate web application, often with its own codebase and development team. The variation in security quality across subdomains means some are much more vulnerable than others. A narrow scope program might have only 2 URLs to test, which limits your surface and makes it harder to find unique findings. Response time matters for your motivation and cash flow. Programs with average triage times measured in days rather than months reward your work faster and give you feedback you can learn from immediately. HackerOne and BugCrowd both publish response time statistics for each program. Filter for programs with responsive triage teams. Payout ranges indicate both the program's security maturity and the competition level. High maximum payout programs attract the most experienced researchers who will have already found many obvious vulnerabilities. New programs, smaller companies, and programs that recently expanded their scope often have less coverage and more opportunities for researchers at the beginner and intermediate levels. Technology match with your expertise gives you an unfair advantage over researchers who are generalists. If you know PHP frameworks deeply, PHP-based programs become disproportionately productive for you. If you know React and GraphQL APIs well, programs built on those technologies are your natural territory. Bug Bounty Recon is what separates researchers who consistently find unique vulnerabilities from those who compete with everyone else on the same obvious targets. The goal is to find attack surface that other researchers haven't thoroughly covered. Subdomain enumeration is the foundation. Tools like subfinder query dozens of passive sources, certificate transparency logs, search engine indexes, API aggregators, and historical DNS data. Amass combines passive enumeration with active DNS brute force. Running both tools and deduplicating their outputs gives you the most comprehensive subdomain list available. Each live subdomain is a separate application that deserves its own investigation. Port scanning beyond port 80 and 443 discovers services running on non-standard ports. Development servers, staging environments, admin interfaces, and internal APIs frequently run on ports like 8080, 8443, 3000, or 5000. A company's in-scope IP ranges might include tens of thousands of IP addresses. A mass scan at fast rate across all of them followed by targeted map for version detection against discovered services reveals the full scope of what's running. Technology fingerprinting with httpx and whatweb gives each discovered host a technology profile. Different technologies have different common vulnerability patterns. When you know a host runs an outdated version of WordPress, WPScan is your next tool. When you know a host uses a specific Java framework, you check for deserialization vulnerabilities specific to that framework. Historical URL discovery through the Wayback Machine and tools like Gow finds endpoints that existed in the past and might still be accessible. Development endpoints, admin panel. The automated Recon pipeline automates the time-consuming initial reconnaissance phase so that by the time you start manual testing, you already have a comprehensive map of your attack surface. The script creates an organized directory structure for each target domain. This keeps your reconnaissance data organized for reference and makes it easier to identify when new assets appear compared to previous scans. The subdomain discovery phase combines subfinder and Amass to maximize coverage from different data sources. Subfinder queries certificate transparency and passive API sources. Amass adds DNS brute force and additional passive sources. Combining both and deduplicating with sort unique gives you the most comprehensive list available. Live host checking with httpx filters your subdomain list to only those currently serving HTTP or HTTPS. This eliminates DNS entries pointing to offline or non-web services that would waste time during manual testing. httpx also collects response codes, page titles, and technology information for each live host, giving you your first fingerprinting data. JavaScript secret scanning is an increasingly important step. Modern web applications are heavily JavaScript-driven and developers frequently commit code with hard-coded credentials, API keys, and internal endpoints. The Katana web crawler discovers JavaScript files across your target. Secret Finder then analyzes each JavaScript file for patterns matching API keys, tokens, credentials, and internal URLs. This automated analysis frequently reveals findings that manual testing would miss entirely. Keep all output from your Recon pipelines and rerun them periodically. New subdomains, new features, and changes to existing. Understanding which vulnerability types pay the most and why helps you allocate your testing time effectively. The highest value bugs are consistently the ones with the highest potential impact on the company's data, infrastructure, or users. SSRF with access to cloud metadata credentials is frequently the highest payout vulnerability type in cloud-hosted applications. When you can make the server fetch 169.254.169.254 and retrieve AWS IAM credentials, you've demonstrated the potential for a complete cloud environment compromise. The impact is enormous and the fix is immediate because companies can't delay addressing credential exposure. SQL injection with demonstrated data access is consistently a critical finding. The key word is demonstrated. A proof of concept that shows actual database content, even synthetic data you've entered yourself, proves the impact concretely. Generic SQL injection reports without demonstrated access are sometimes downgraded in severity. Show the number of database rows, the table names, or a sanitized example of the data structure without including real user personal information. Authentication bypass vulnerabilities that allow login without valid credentials or that allow regular users to access administrator functionality are high-severity findings with immediate business impact. These are the types of vulnerabilities that make executives nervous because they demonstrate a fundamental failure in the application security model. Remote code execution is the holy grail. A finding that gives you command execution on company servers demonstrates complete infrastructure compromise. These are rare in mature bug bounty programs, but when found they pay exceptionally well. Bug chains are often how researchers create critical findings from individually lower severity components. Bug chaining is the technique of combining multiple lower severity vulnerabilities to create a higher severity attack chain with greater impact. This approach finds high-severity findings in applications that appear to have their individual vulnerabilities under control. The IDAR plus PII exposure chain illustrates why impact determines severity more than vulnerability class. An IDAR that lets you access another user's profile preferences is typically medium severity. The profile preferences themselves are not sensitive. But an IDAR in the same application that lets you access another user's payment history, medical records, or private messages is high severity because the data exposed is genuinely sensitive. The vulnerability class is the same, IDAR, but the impact varies dramatically based on what data is accessible through it. The XSS session theft chain shows why context matters for XSS. Pure self-XSS that only executes in your own browser is typically not accepted by bug bounty programs. It doesn't affect other users. But if you can find a way to deliver that XSS to another user through their profile viewing, notification delivery, or content sharing, it becomes stored or reflected XSS with session theft capability. The chain is finding the delivery mechanism for an otherwise self-only vulnerability. The SSRF to internal network chain is one of the most powerful. Basic SSRF that hits public IPs isn't very interesting. But when you demonstrate that SSRF reaches internal services, whether the AWS metadata endpoint, a Redis instance without authentication, or an Elasticsearch cluster, you've turned a medium finding into a critical one. The vulnerability is the same, but the reach determines the impact. Open redirect to OAuth token theft requires finding two separate. The systematic testing approach for bug bounty hunting differs from penetration testing in one important way: you're competing with other researchers who are testing the same application. Systematic coverage of the entire attack surface before going deep on any single area is what finds unique bugs that competitors miss. Mapping all functionality as a normal user sounds obvious, but most researchers skip directly to attack tools. Walking through every user journey, every feature, every setting page, and every interaction gives you a mental model of the application that automated tools can't replicate. You understand the business logic, the data flow, and the application's security model. This understanding guides your testing more effectively than any automated scanner. Identifying trust boundaries is where your mental model of the application pays off. Trust boundaries are the points where the application makes access control decisions, checking authentication, verifying authorization, validating input, evaluating business rules. These are your primary testing targets because security failures at trust boundaries have the highest impact. Testing authentication flows thoroughly catches a category of vulnerability that's surprisingly common: password reset weaknesses. Reset token generation using predictable values like timestamps, extremely short tokens that are brute forceable, tokens that don't expire, and reset flows that can be used on other users' email addresses are all regularly found in real applications. Testing multiple user roles by registering accounts at different privilege levels lets you test horizontal access control by trying each account's requests with the other account session. Creating premium and free tier accounts lets you test whether free users can access premium features by manipulating request parameters. New feature releases are the highest probability target for any program. API testing is disproportionately productive in modern bug bounty programs because APIs are where the actual business logic and data operations live in contemporary applications. The frontend just calls the API and displays results. The API makes the authorization decisions. API documentation discovery is often the first win. Many companies deploy Swagger or OpenAPI documentation at known paths that expose the complete API schema. This documentation reveals every endpoint, every parameter, and every expected data type. What it doesn't reveal is whether the authorization on those endpoints is correctly implemented. Test every endpoint in the schema with requests from different user accounts and permission levels. HTTP method testing against each endpoint is something many researchers skip and many developers forget to implement. An endpoint correctly secured against GET requests might allow delete or put without authentication. Trying every standard HTTP method against each endpoint you find, including options, patch, and head, catches authorization gaps that attack surface mapping with a browser alone will completely miss. Mass assignment is a vulnerability pattern that appears consistently in REST API applications. When an API update endpoint accepts a JSON body, developers sometimes implement it by directly mapping request body fields to database model fields without explicitly specifying which fields users should be able to modify. Submitting extra fields like isAdmin, role, or verified in your update request and checking whether the application accepts and applies them tests for mass assignment. A 200 response that reflects your modified field in the response confirms the vulnerability. This finding appears regularly even in well-resourced programs because it's a pattern issue. Mobile application security is one of the most productive but underexplored areas in bug bounty hunting. Many researchers focus exclusively on web applications, leaving mobile apps as less competed territory with significant attack surface. Android APK reverse engineering starts with downloading the APK. Either from the Google Play Store using a downloader tool or directly from the device using ADB. The JAX decompiler converts the Dalvik bytecode back into Java source code that's readable. Aptl decompiles to Smalley assembly and extracts resources. In the decompiled source, search for hard-coded API keys, encryption keys, backend URLs, and hard-coded credentials. Developers frequently hard-code these values in mobile apps naively believing the code is not readable. This assumption is wrong. Certificate pinning bypass is the key technical challenge for traffic interception. When an app implements pinning, it refuses to trust any certificate not matching a hard-coded public key, which prevents Burp Suite from intercepting https traffic. Frida is a dynamic instrumentation framework that injects code into running processes. The SSL pinning bypass script for Frida hooks the certificate validation code at runtime and forces it to accept any certificate including burps. This works without modifying the APK and without jailbreaking on many Android versions. Once traffic is intercepted, you apply the same web application testing methodology. The API endpoints, authorization mechanisms, and server-side vulnerabilities are identical to what you test in a browser. Many mobile apps expose API endpoints that have less security review than the web-facing API because developers assume mobile traffic is harder to intercept. Report writing is the skill that determines whether your valid findings get paid, how much they pay, and what your long-term reputation in the bug bounty community becomes. Technical skill finds the bugs. Writing skill gets them accepted and rewarded fairly. The title is the first thing a triage engineer reads and it sets their expectation for everything that follows. A title that precisely describes what's vulnerable, where, and the specific impact tells the triage engineer immediately that you understand the severity and have provided something specific. Compare SQL injection found to unauthenticated SQL injection in the product search endpoint allows reading all customer records including email addresses and hashed passwords. The second title communicates severity, location, and impact in one sentence. Reproduction steps are the technical heart of the report. Number each step. Include exact values, the specific URL, the exact parameter name, the specific payload you used, the exact response that demonstrates the vulnerability. A triage engineer should be able to reproduce your finding in under 5 minutes by following your numbered steps exactly. When they can't reproduce it, your report gets marked as informational or needs more information and payment is delayed. Demonstrated impact is what converts a technical finding into a business risk. Don't say, an attacker could access the database. Say, I accessed the user's table and observed, number, rows containing email addresses and password hashes in BCRYPT format. I did not retrieve or store any user data. The distinction between what's possible and what you actually demonstrated matters. CVSS scoring demonstrates professional knowledge. Use the CVSS 3.1 calculator at first.org to compute an accurate score. Let me walk through the professional report template in detail. The title should be one precise sentence. In the example, we have the vulnerability type, the specific endpoint, and the specific impact. Someone who reads only the title knows this is a SQL injection in the search API that allows database access without authentication. The severity line includes both a qualitative label and the CVSS numerical score. Including both gives triage engineers the context they need to prioritize. Critical with a 9.8 CVSS score communicates that this should be escalated immediately. The steps to reproduce are numbered and precise. Each step includes the exact URL, the exact input, and the exact action. Nothing is assumed. Nothing is left ambiguous. If the vulnerability requires specific account state, the steps describe how to set that up. The impact statement is precise about what is possible. We describe specifically that an unauthenticated attacker can read data from the user's table and characterize what that data contains. We explicitly state that we did not access real user data. This is the responsible data handling statement that demonstrates you understand the ethical boundaries even while demonstrating technical capability. The remediation section gives specific, actionable guidance. Not fix the SQL injection, but implement parameterized queries in the product search endpoint SQL construction. Triage engineers often pass remediation guidance directly to development teams. Specific guidance that a developer can act on immediately is more valuable than generic category guidance. Screenshots are mandatory for every report. Record a video proof of concept for critical findings. Visual evidence is understanding how programs classify severity helps you set accurate expectations and communicate your findings effectively. The severity tiers broadly correspond to impact scope and exploitability conditions. Critical findings, sometimes called P1, are those that require immediate action from the security team. Remote code execution on production servers, SSRF with demonstrated access to cloud credentials, SQL injection with access to all customer data, and mass account takeover via authentication bypass all fall here. The combination of widespread impact and ease of exploitation defines critical severity. Payouts at this level range from $5,000 to $50,000 or more on major programs. Some programs have paid six figures for exceptional RCE findings. These reports get immediate triage attention and often result in emergency patches. High-severity findings, P2, demonstrate significant impact affecting real users or data in a contained way. Single account takeover through IDOR or authentication flaw, either exposing sensitive personally identifiable information, stored XSS in admin panels that compromises admin sessions. These typically pay $500 to $5,000 and get triaged within 1 to 2 weeks. Medium severity findings, P3, demonstrate real impact with limited scope or exploitation conditions. Self-XSS with some external trigger requirement, rate-limiting absence on password reset that enables enumeration, CSRF on non-critical account actions. These pay $50 to $500 and get addressed in normal release cycles. The key insight is that severity is about business impact, not just the vulnerability class. And SQL injection that accesses only non-sensitive public data. The most commonly reported bugs in bug bounty programs follow patterns that you can learn and apply systematically. These are not the rarest or most exotic vulnerabilities. They're the ones that appear most frequently because they reflect common development mistakes that show up consistently across many applications. IDOR is the champion of bug bounty findings by volume. Every application that has user-specific resources has IDOR testing opportunities. Every API endpoint that takes an ID parameter should be tested by changing that ID to values belonging to other users. Testing sequentially, testing with IDs from other accounts you control, and testing with negative numbers and zero catches most IDOR implementations. Missing authentication on API endpoints is found constantly because developers sometimes forget to add authentication middleware to specific routes, or because they add routes to a framework router without the authentication decorator. Test every endpoint in the application with an invalid or absent authentication token. Any endpoint that returns real data without requiring valid authentication is a finding. Stored XSS in user-generated content is common because sanitization is harder than it appears. Different rendering contexts require different encoding. Content that's safe in one context becomes executable in another. User profile fields, comment boxes, product descriptions, and notification content are all high-value testing targets for stored XSS. Open redirect is often dismissed by beginners, but when properly chained with OAuth authentication flows, it becomes a high-severity account takeover chain. Information disclosure through stack traces, version numbers, backup files, and directory listing doesn't pay well alone but provides valuable context for escalating other attacks. Subdomain takeover is one of the most valuable techniques for bug bounty hunting because it's systematic, scalable, and consistently produces valid findings across many programs. Understanding it deeply lets you apply it everywhere. The vulnerability exists when a company creates a name DNS record pointing a subdomain to an external service provider, then stops using that service but forgets to remove the DNS record. The DNS record still points to the external service. If that service allows new registrations, anyone can register the same service slot and take control of all traffic to that subdomain. Since the DNS record uses a legitimate company subdomain, the attacker's content appears to come from the company's trusted domain. The detection process starts with your comprehensive subdomain list from Recon. For each subdomain that returns a specific type of error, you check whether the service it's pointing to is available for registration. The error messages vary by service. GitHub Pages says, "There isn't a GitHub Pages site here." Heroku says, "No such app." Azure says, "The site is not configured." Each service has a characteristic error message that indicates the slot is unclaimed. Subjack automates this check against your entire subdomain list. It knows the error patterns for dozens of services and reports candidates automatically. Review the candidates manually to confirm before claiming anything. The impact of successful subdomain takeover is significant. You control httpx content on a legitimate company subdomain. You can set cookies for the parent domain's subdomain scope. You can serve phishing pages that appear to be on the company's own domain. You can bypass content security policies that trust the subdomain. You can intercept traffic from the company's own app. Automation in bug bounty hunting is not about replacing manual testing. It's about scaling the reconnaissance and initial discovery phases so that your manual testing time is focused on the highest probability targets. The automation stack shown here represents the tooling used by productive bug bounty hunters who work multiple programs simultaneously. The asset discovery and monitoring pipeline combines subfinder for passive subdomain enumeration with httpx for live host checking and basic fingerprinting. Piping the output directly and using T to save to a file simultaneously gives you both a file for later reference and a live stream for monitoring. Subjack runs across your complete subdomain list checking for takeover candidates against dozens of known service patterns. Running this on a large subdomain list frequently surfaces opportunities that manual browsing would miss. Nuclei's template-based vulnerability scanning against your live host list provides automated checking for thousands of known CVEs and misconfigurations. The CVEs template directory alone covers thousands of known vulnerabilities. The exposures and misconfiguration directories catch common security issues. This automated pass identifies the low-hanging fruit quickly. The parameter discovery and SQL injection pipeline using Katana for crawling, GF for filtering URLs containing parameters, and SQLmap for automated injection testing creates an end-to-end automated SQL injection discovery workflow. Use this carefully and only on in-scope targets that explicitly permit automated testing in their program policy. The monitoring script that tracks new subdomains over time represents a competitive advantage. Programs continuously add new subdomains as they launch new products, services, and features. Being the first researcher to test new assets means less competition. The security researcher mindset is what separates researchers who consistently find unique high-severity vulnerabilities from those who compete on obvious findings with diminishing returns. Thinking about what developers assumed is the core skill. When a developer wrote the code you're testing, they made assumptions about how users would interact with it. They assumed users would log in before accessing protected resources. They assumed users would only submit their own ID in update requests. They assumed users would not modify the HTTP method on requests. They assumed the frontend would only call APIs with the parameters it was designed to use. Every one of these assumptions is a potential vulnerability when an attacker doesn't share them. Your job is to systematically violate every assumption and observe what happens. Following the data flow through an application reveals injection points that surface-level testing misses. When user input enters the application through a search box, where does it go? Does it get stored in a database with a query that might be injectable? Does it get rendered in an email notification that might be vulnerable to XSS? Does it get included in a file path that might enable path traversal? Does it get passed to a shell command that might be injectable? Tracing input from entry point through every processing stage and to every output point maps the complete injection surface. Reading company changelogs and blog posts for feature announcements is the most reliable way to find under-tested targets. New features are code written under deadline pressure by developers who were focused on making the feature work, not on securing it. The security review process for new features is often less thorough than for existing code. Within days of a feature launch, there's a window where you can test it before other researchers have thoroughly covered it. The bug bounty career path requires patience and a clear progression mindset to navigate effectively. Let me give you an honest roadmap of what the journey actually looks like. Building your technical foundation before attempting bug bounty is genuinely important. Researchers who start hunting without solid fundamentals in web application security, network security, and at least one scripting language spend most of their time frustrated rather than learning. The knowledge from episodes 2 through 7 in this series is the minimum viable technical foundation. Add Portswigger Web Security Academy labs on top of that for web-specific depth. Starting with public programs on HackerOne is the standard beginning. Public programs have published policies that are legally clear. They accept reports from all researchers. They provide feedback on submissions even when you don't receive a payout. Your first 5 accepted reports, even for low or informational findings, are more valuable than your next 50 because they teach you the report writing format that gets submissions triaged successfully. Getting your first reports accepted matters more than earning significant money initially. Your first 5 reports will likely be low severity. That's normal. They establish your profile, teach you the triage process, and most importantly, show you the gap between what you thought was a finding and what the program actually accepts. This calibration is invaluable. Building reputation through consistently quality reports over months opens private program invitations. HackerOne's signal score measures your submission quality based on triage outcomes. A positive signal score demonstrates to program managers that you submit valid, well-documented reports. Private programs have significantly less competition than public ones. The same vulnerability that would be a duplicate. The bug bounty learning ecosystem is rich and much of the best content is completely free. Let me point you to the resources that actually produce skill growth rather than just entertainment. Public HackerOne disclosures are the most valuable learning resource available. Real vulnerabilities, real programs, real reports written by researchers who were paid for them. Reading these reports teaches you what valid findings look like, what report quality gets rewarded, and what vulnerability patterns appear across different applications. The HackerOne Hacktivity feed shows recent public disclosures. Filter by your target programs or by vulnerability type. Read at minimum 5 reports per week from researchers who are more experienced than you currently are. Pentesterland at pentester.land/list of bug bounty write-ups curates the best bug bounty write-ups from across the internet. Organized by vulnerability type and application category, this resource lets you deep dive into specific vulnerability classes when you're preparing to test programs in a particular technology stack. Portswigger Web Security Academy at portswigger.net/websecurity is the most comprehensive interactive web security training available. Every lesson includes an interactive lab where you practice the exact vulnerability being explained. The expert-level content goes significantly deeper than most commercial courses. Complete the entire learning path. Naim SEC, whose real name is Ben Sadegapur, is one of the most respected bug bounty hunters and educators. His YouTube channel includes live hacking sessions where you can watch professional methodology applied to real programs in real time. Observing how he thinks about application behavior and vulnerability discovery is better than any course that teaches technique in isolation. Bug bounty forum and relevant Reddit communities. Let me give you an honest picture of bug bounty earnings at different experience levels because unrealistic expectations either lead people to quit when results don't meet fantasy expectations or to undersell themselves when they've actually developed genuine professional skill. At the beginner level during your first 6 to 12 months, your submissions will mostly be informational or low-severity findings. Duplicates are common because popular programs have been heavily tested. Expect $0 to $500 per month from bug bounty work. This sounds discouraging, but it's the phase where the most foundational learning happens. Your first duplicate tells you that other researchers are looking at the same things. Your first triaged finding tells you your instincts are developing correctly. Your first payout tells you this is real. Stay consistent through this phase. It's the investment period. At intermediate level, after 12 to 24 months of consistent work, you're finding medium severity vulnerabilities regularly and occasionally hitting high severity. Some private program invitations should be appearing. Earnings of $500 to $3,000 per month become realistic for dedicated researchers who work this consistently. The key difference from the beginner phase is methodology. You're not testing randomly or following tool output blindly. You're systematically covering attack surface with an understanding of what's likely to be vulnerable. At advanced level, after 3 or more years of focused bug bounty work, primarily private programs, consistent critical and high-severity findings, and a reputation that earns top program invitations, monthly earnings of $5,000 to $50,000 or more become achievable. The top handful of bug bounty researchers globally earn in the hundreds of thousands annually. These are outliers, but they're real. The Path, Episode 8 complete. You now have the complete bug bounty framework, platform selection and getting started, program selection strategy for your skill level, the automated Recon pipeline that maps attack surface other researchers miss, the highest value vulnerability types and how to chain them, professional report writing that gets your submissions accepted and fairly rewarded, mobile application testing as an underexplored opportunity, subdomain takeover as a scalable systematic finding, automation that multiplies your coverage, and a realistic career path from first report to private program invitation. Here's your action item: create your HackerOne account today if you haven't already. Read 5 public disclosure reports. Then pick one beginner-friendly program with a wide scope and read its scope document completely. That's your starting point. Episode 9 is the final episode in this series and it covers security research. We're going beyond the practitioner level into understanding how researchers discover new vulnerability classes, how they analyze unknown software, how they contribute to the security community through responsible disclosure, and what the career path in professional security research looks like. If you want to understand not just how to use techniques but how those techniques were discovered, Episode 9 is for you. Subscribe. The final episode drops soon. I'll see you there.